Hello and welcome. This is going to be our lecture video for the kinetic and potential energy worksheet. This is going to be our quiz review. So the quiz will look very similar to this worksheet. I will simply look at this worksheet as I write the quiz questions. So as long as you can do all of these well, you'll be able to do well on that quiz. So classify the following as a type of potential energy or kinetic energy. A bicyclist pedaling up a hill. So if they're pedaling, they're moving. So they must have kinetic energy. Kinetic energy is the energy of motion. An archer with his bow drawn. So nothing is actually moving here. All right. The bow itself flexing is going to store some energy that is released once they release the bow. But until that arrow is released, it's all just storing up potential energy. Striking a ball, so striking, I consider that to be moving. You could say there's some potential energy there as the ball compresses and then that's released, but I think that's kinetic energy. Thrown, chemical bonds are a form of potential energy. The wind is blowing through your hair, so it's moving. Walking, sitting. So is there any energy here? Because we're on top of the tree, it's going to have lots of gravitational potential energy, the potential for you to fall out of the tree. Bowling ball rolling down an alley and sitting on a rack, same concept. It's potential energy because it could fall off the rack, it could fall into the basement. Until you're at the center of the earth, you still have some gravitational potential energy. I will let you come up with your own examples here. All right, now to fill in these blanks, what we should say for the first one, since the next one says greater, we should say the slower an object moves, the less energy it has, the greater the speed, or maybe we should say velocity because we're in physics, but I'll just write speed, the more energy it has. If that makes grammatical sense. The greater the speed of a moving object, the more energy it has. Kinetic energy depends on both. Well, let's think about the formula. It depends on both mass and velocity. All right, moving on. You serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has kinetic energy because it's moving. It also has potential energy, but we don't have the information about its potential energy. We just have information about its kinetic energy. Let's calculate it. It's going to be 0.5 times the mass, 2.1 times the velocity squared. Let's check that everything's in SI units. Kilograms and meters per second is perfect. And now we're just going to plug this into our calculators to get our final number. Zero 0.5 times 2.1 times 30 squared. We got 945. And the unit for energy is joules. All right. Baby carriage is sitting at the top of a hill that's 21 meters high. The carriage with the baby has a mass of 1.5 kilograms. It's actually insanely light, but here we go. The carriage has potential energy. Calculate it. So the formula for this is just mgh. So the mass was 1.5 kilograms. G, as long as this is on Earth, should be 9.8. And the height is 21 meters, and it does have to be in meters. So we'll plug that in. And we get 308.7 joules of potential energy. I guess with the correct sig figs, it'd be 310 joules. All right, and the next one is kinetic, and I think I will skip that one. All right, problem 18 here. A cinder block is sitting on a platform 20 meters high, so it's sitting. So that's our kind of indication that this is going to be potential energy. We've got a height, we have a weight, so we'll just do potential energy equals mgh. Mass 7.9, gravity is 9.8, height is 20. So 7.9 times 9.8 times 20 equals 1,548 joules of energy. The next one, we got another kinetic energy one. Maybe I'll just set this one up. Oh wait, it's not kinetic energy because it is at the top, but it hasn't started dropping yet. So this one still is potential energy. And then we'll do mgh. Bell at the top of tower. This can be some more potential energy. Next, let's look at 21. Kinetic energy of a 1,000 kilogram roller coaster moving at the speed of 20 meters per second. So let's write out that formula again. Kinetic energy is 1/2 mass times velocity squared. And although it's 1/2, I like to use 0.5 because that's easier to plug into the calculator and avoid mistakes. So 0.5 times 1,000 times 20 squared, and you can, let's see, that's 400, half of that is 200. So this would be 200,000 joules, 200,000 joules of kinetic energy. All right, it's moving with twice the speed. Its new kinetic energy, because velocity gets squared, would then be 4 times as much. And you can just most easily figure that out by just reevaluating the problem with 40 instead of 20 for the velocity, and you will get a number that's 4 times as high. Velocity really scales up quickly with energy because of that squared there. Next one, cart is loaded with a brick and pulled at a constant speed along an inclined plane to the height of a seat top. If the mass of the loaded cart is 3 kilograms and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart? So all of that setup, we still just use mgh. Oh, my pen, mgh. Mass is 3, g is 9.8, and the height is 0.45. So it doesn't matter how it got there. Once it gets to that point, its potential energy will always just be calculated by mgh. We've got another one about a refrigerator. We'll use mgh again, and then another one where we have to solve it backwards. So this one's worth doing. Here we go. So we know that potential energy equals mgh. This time we're told the mass is 40. We know gravity is 9.8. We don't know the height, but we know the potential energy is 1,000 or 14,000 joules. All right, so let's do the 40 times the 9.8 and then do the 14,000 divided by that. So 14,000 divided by, in parentheses, 40 times 9.8. And we get a height of 35.7 meters. So if most of the energy we use on this Earth comes from the sun, how does that energy, light and thermal, end up as blank energy in our food? So what we're looking here is chemical potential. Right, small. You could just say chemical energy because all chemical energy is chemical potential. but this is, I guess, more precise. As blank energy of wind, so that'd be just kinetic energy of wind or moving water. I think actually probably just wants potential kinetic. Um, as so it's electrical energy that powers our lights. It's technically electrical potential, but you could think of it as sort of kinetic because the electrons do move through the wires, but it's really, we almost always refer to it as electrical potential energy that's in the wires. And then that potential energy is converted into things like light and heat in a light bulb. Or as blank energy, when we move around, that's some more kinetic energy. And where did that energy still came from the sun? It had to be converted into chemical potential energy through a process called photosynthesis, and then reconverted to kinetic energy through a couple processes in cells. One of them would be respiration, and then that the product of that ATP goes to our muscles, and then muscles can use that transformed chemical potential energy to create kinetic energy. All right, next page. All right, law of conservation of energy. Energy can be neither, hopefully you've heard me say this, created nor destroyed by ordinary means. We have to throw the word ordinary because technically through processes like fission and fusion, you can convert energy to mass and vice versa, but outside of those extreme circumstances, like the center of a star, energy is never lost, it's only ever converted. So that answers our next thing. Energy can be converted, or another word is transformed, from one form to another. The total amount of blank is the blank before and after any energy transformation. The total amount of, I guess, energy is the total before and after energy transformations. Yeah, I think that fills that in appropriately. Maybe that's not exactly what they're looking for, but I'm okay with that. Energy transfer is the blank from one object to another object. This one, the best answer I can think of is to just say the word transfer of energy again. I do not know what else could go into that blank. So energy transfer is the transfer of energy from one object to another object. Example, a cup of hot tea has thermal energy. If it's hot, some of this thermal energy is blank to the particles in cold milk, so transferred. In which you put to make the coffee colder. All right, you can skip this next section. I don't think it makes a whole lot of sense. One thing we haven't said is that kinetic energy and potential energy can be grouped together under one title, which is mechanical energy. So there's no real place to put this in here, but maybe just write it KE and PE are both mechanical energy. All right, and let's talk about roller coasters. As you move up the first hill on a roller coaster, the distance between the coaster and the earth increases. result in an increase of potential energy. At the top of the first hill, you have high gravitational potential energy. As you begin your trip down the hill, you blank your speed, so increase your speed, resulting in a transformation from potential energy to kinetic energy. At the bottom of the hill, right before it goes back upwards, the potential energy is low, but the kinetic energy is high. As it starts moving up the next hill or loop, kinetic energy is converted or transformed back into gravitational potential energy. All right, so that's that for this worksheet and lecture video. Have a good rest of your day.